Okay, let's now talk about how to evaluate the pros and cons of the implementation we just took a look at. So this solution that we just walked through fixes some of the limitations and problems with the earlier executor PrimeChecker implementation. In particular, the fact that we used two-way callable semantics decoupled the prime callable from the main activity so they didn't have to know about each other. And that helps to simplify runtime configuration changes because when things change, we don't have to update all the prime callables. It's just handled automatically. Because we now have the lifecycle operations built into the executor service versus the executor, we can handle task interruptions. So if we come along and interrupt the executor service or interrupt the thread and so on, those things are much more responsive, and that wouldn't have been possible with the executor implementation because there's no way to manage the life cycle of anything. So when we shut down the executor service, all the threads are automatically interrupted so they can voluntarily shut down, which they should do, of course. The isPrime method checked to see if it was interrupted, so that was another feature we built into this. We didn't have that before, so it'll automatically check and shut itself down as needed. And we can also handle runtime configurations gracefully because when things rotate, the running tasks are still executing in the background because we've retained the state in a special way that doesn't get blown away when the activities come and go. And all we have to do is just get the new activity to show up and start displaying from where we left off. So it's very clean and cool. But of course, there's still some limitations. Some of these limitations are shared with the executor service. Some of the limitations are shared by the executor service with the earlier executor implementation. Others are different. So one of the problems here is that the get method will block the thread even if the other futures may have completed. So remember, get will always block. You can use a timed call, of course, but same problem. How long do you time out? What do you do when you time out? And this is a problem that's inherent with the so-called synchronous future processing model. So what's happening here is even though we're running the computations asynchronously, we are waiting for the futures to complete synchronously. So we're waiting for them in a loop, and they have to wait in that loop in some order. And then we wait for them synchronously by calling get. So it solves some of the problems, but not all the problems. And we'll show how to fix this problem later when we talk about the Java Executor Completion Service, which really solves the problem. We also use this brute force checker, which first takes a while to run, so we might want to do another implementation that's faster. But even more important, whether it's a faster implementation or not, we might want to avoid having to recompute whether something is prime if we've already checked that number earlier. So we might want to have another approach where we cache the results of previous prime checking operations and then simply look up in the cache to see if we've already got a number for that. And only if we haven't got a value for that, then go ahead and run this isPrime computation, either the slow one or the fast one. It's definitely going to be faster to look it up in a list, in a hash map, however, than it will be to recompute it from scratch. So that's yet another problem. It's tightly coupled. We can't make those changes without breaking existing code. So that's the end of our discussion on pros and cons of the executor service.